On a crisp autumn evening in 1957, a simple beeping sound echoing from the heavens changed our world forever. It was October 4th, and humanity had just taken its first real step toward the stars. That persistent beep beep beep, transmitted from a small metal sphere orbiting high above Earth, marked the moment when our species transcended its earthly bounds and began its greatest adventure. This humble beginning, the launch of Sputnik 1, represented far more than just a technological achievement. It was the moment when science fiction became science fact, when the impossible became possible, and when humanity collectively looked up at the night sky with new eyes. That small metallic sphere, no larger than a beach ball, opened the gateway to the cosmos and sparked a journey that would transform human civilization. In the 65 years since that historic moment, we've witnessed an extraordinary transformation in our relationship with space. What began with a simple satellite that could only emit basic radio signals has evolved into an era where rockets gracefully land themselves vertically, just as we once imagined in science fiction stories. We've progressed from tentative first steps in low Earth orbit to maintaining permanent human presence in space, from grainy black and white photos of Earth from space to high-definition images of distant galaxies. This is not just a story of technological advancement. It's the tale of how humanity transformed itself into a spacefaring species. Every launch, every mission, every triumph, and yes, every tragedy has added another chapter to this remarkable journey. We've sent robotic explorers to the far reaches of our solar system, placed our footprints on the moon, and now stand on the brink of becoming a multiplanetary species. The beeping of Sputnik may have long since fallen silent, but the echo of that historic moment continues to resonate through time. Today, we'll embark on an epic journey through these transformative decades that forever changed our perspective of our place in the cosmos. From the height of the space race to the dawn of commercial spaceflight, from government-led exploration to private companies reaching for the stars, this is the story of humanity's greatest adventure. If you've ever looked up at the night sky and felt that irresistible pull of the unknown, if you've ever wondered how we went from dreaming about the stars to reaching out and touching them, then join us on this incredible journey. Together, we'll explore how a species that once gazed at the stars in wonder learned to dance among them. Welcome to Exploring the Universe, where we'll uncover the remarkable story of how humanity became a spacefaring civilization. The launch of Sputnik 1 represented more than just a scientific milestone. It was a cultural and political earthquake that shook the world to its foundations. Imagine the profound psychological impact of that moment. For the first time in our species' long history, humans could look up at the night sky and know that among the countless natural celestial bodies, there was now something artificial, something we had created silently passing overhead. To grasp the magnitude of this achievement, consider what it meant to people in 1957. In an age when many homes still didn't have television sets and commercial jet travel was in its infancy, the Soviet Union had managed to place an object into orbit around our planet. The public reaction was a mixture of awe, fear, and disbelief. People would gather in their backyards, tracking the satellite's path across the night sky, its presence announced by that now famous radio signal that could be picked up by amateur radio operators worldwide. But beneath the scientific achievement lay a more complex reality. The space race was, in many ways, a new theater in the Cold War. The same rocket that could carry Sputnik into orbit, the R-7 intercontinental ballistic missile, demonstrated the Soviet Union's capability to deliver nuclear weapons across continents. The space above our heads had suddenly become the new frontier of superpower competition, transforming the peaceful realm of astronomical research into a battlefield of technological and ideological supremacy. The American response to Sputnik was nothing short of revolutionary. The initial shock and fear of falling behind their Cold War rival quickly crystallized into a national determination to catch up and surge ahead in the space race. This crisis of confidence led to the creation of NASA in 1958, transforming the existing National Advisory Committee for Aeronautics into a new agency with a bold mission to establish American leadership in space exploration. Project Mercury, America's first human spaceflight program, emerged from this determination. The project's goals were ambitious yet clear. Put an American in space, bring them back safely, and do it before the Soviets. The Mercury program selected 7 pilots from military test flight programs, the famous Mercury 7, who would become America's first astronauts. These men, chosen from hundreds of candidates, embodied the nation's hopes and determination to prove that American technology and ingenuity could match and exceed Soviet achievements. The development of Project Mercury marked a crucial shift in American scientific and technological priorities. The government poured unprecedented resources into science education, engineering research, and technological development. Universities expanded their science programs, and a new emphasis was placed on mathematics and engineering in public education. What had begun as a moment of national anxiety had transformed into a catalyst for one of the most significant technological mobilizations in human history. This period between 1957 and 1961 set the stage for what would become humanity's greatest adventure. The competition between the United States and Soviet Union, while born from Cold War tensions, would ultimately drive both nations to achieve what had previously seemed impossible. The fear and uncertainty following Sputnik's launch had indeed transformed into determination, not just to compete in space, but to understand it, to reach it, and ultimately, to explore it in ways that would benefit all of humanity. As we look back on this pivotal era, we can see how a single beeping satellite served as the catalyst for a technological revolution that would change our world forever. The space race had begun, and with it, humanity's first coordinated steps into the cosmic ocean that surrounds our planet. The years between 1961 and 1969 would come to be known as the golden decade of space exploration, a period that would witness humanity's greatest achievements in space and forever change our perspective of what was possible. On April 12, 1961, a 27-year-old Soviet pilot named Yuri Gagarin became the first human to journey into space. As his Vostok 1 spacecraft prepared for launch, Gagarin's final words captured the spirit of that historic moment. Poekali, let's go! This simple, enthusiastic exclamation would become a symbol of human courage and optimism in the face of the unknown. For 108 minutes, Gagarin orbited the Earth, experiencing what no human had ever felt before. The sight of our blue planet suspended in the vast darkness of space, the sensation of weightlessness, and the knowledge that he had broken the final frontier. The United States, still reeling from being second in this crucial milestone, needed a bold response. It came on May 25, 1961, when President John F. Kennedy addressed Congress with what seemed like an impossible promise: to land a man on the moon and return him safely to Earth before the end of the decade. The audacity of this goal cannot be overstated. At the time, America had only managed to send Alan Shepard on a 15-minute suborbital flight. Choosing to go to the moon, when we barely knew how to fly in space, was like deciding to cross the Pacific Ocean when we had barely learned to build a raft. To bridge the vast technological gap between suborbital flights and lunar landings, NASA initiated Project Gemini. Operating between 1965 and 1966, Gemini served as America's space laboratory, a crucial testing ground for the techniques and technologies that would be necessary for lunar exploration. Through 10 crewed missions, astronauts learned to rendezvous and dock in orbit, conduct spacewalks, and survive the lengthy durations required for a moon mission. Each Gemini flight pushed the boundaries of what was possible, transforming theoretical concepts into practical achievements. The culmination of this golden decade was the Apollo program, humanity's greatest technological achievement. After the tragic loss of the Apollo 1 crew during a ground test, the program rebounded with remarkable determination. Each mission built upon the success of its predecessors, pushing the boundaries of exploration further. Apollo 8 gave humanity its first view of Earthrise over the lunar surface during Christmas 1968, a photograph that would help launch the environmental movement by showing just how fragile our planet looked from space. Then came the moment that would define the decade. On July 20, 1969, Apollo 11 astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on another world. Armstrong's first step onto the lunar surface and his famous words, "That's one small step for man, one giant leap for mankind," marked the pinnacle of human achievement. For a brief moment, as hundreds of millions watched on television, the entire world was united in celebration of what humanity could accomplish when it dared to dream big. The moon landing represented more than just a victory in the space race. It demonstrated that with enough determination, resources, and human ingenuity, we could achieve what seemed impossible just years before. During this golden decade, humanity had progressed from its first tentative ventures into space to walking on another world, an advancement that remains unparalleled in its scope and speed. Looking back, it's difficult to determine which achievement was more impressive: Gagarin's pioneering first flight or the moon landing. Gagarin's mission opened the door to space exploration, proving that humans could survive in space and return safely. It was the crucial first step that made everything else possible. However, the moon landing represented a quantum leap in complexity and ambition, requiring the coordination of hundreds of thousands of people and the development of entirely new technologies. Perhaps the true answer is that both achievements were essential parts of humanity's greatest adventure, each remarkable in its own way. After the triumph of the moon landings, space exploration entered a new phase focused not on reaching new destinations, but on learning to live and work in space for extended periods. This was the era of space stations, when humanity began to establish its first permanent presence beyond Earth. The story begins with Skylab, America's first space station and the first real home in space. Launched on May 14, 1973, Skylab was created from a modified Saturn V rocket's third stage, demonstrating NASA's ingenuity in repurposing existing technology. However, the mission nearly ended in disaster before it began. During launch, the station's micrometeoroid shield and one of its solar panels were torn away, and the other solar panel was jammed shut. The first crew faced an unprecedented challenge. They would need to repair their home in space before they could even move in. In what would become one of NASA's most impressive demonstrations of improvisation and determination, the first Skylab crew, led by Charles Pete Conrad, performed a series of complex spacewalks to deploy a makeshift sunshade and free the jammed solar panel. Their success turned what could have been a costly failure into one of NASA's greatest triumphs. The repair mission demonstrated that humans could not only survive in space, but could also work effectively to maintain and repair complex systems in orbit. Over the next 9 months, 3 separate crews would call Skylab home, with each staying longer than their predecessors. The longest mission lasted 84 days, setting a new record for human endurance in space. Inside their orbital home, astronauts conducted groundbreaking research in solar astronomy, Earth observation, and the effects of long-duration spaceflight on the human body. They also learned valuable lessons about living in space, everything from how to exercise in zero gravity to the psychological challenges of being confined in a relatively small space for months at a time. But it was the Soviet Union that would take the concept of space stations to the next level with their Salyut program, and, most notably, the Mir space station. Launched on February 19, 1986, Mir, meaning peace or world in Russian, represented a quantum leap in space station technology and operations. Unlike previous stations, Mir was designed to be modular, with new sections added over time to expand its capabilities. What makes Mir's story particularly remarkable is its longevity. The station remained in orbit for 15 years, longer than many people live in the same house on Earth. This unprecedented duration allowed for long-term studies of the effects of spaceflight on human physiology and psychology, as well as the degradation of space hardware over time. Mir became humanity's first truly long-term home in space, hosting crews for stays that would eventually stretch to over a year. But perhaps Mir's greatest legacy was its role in fostering international cooperation in space. During its lifetime, the station hosted astronauts from 12 different nations, including American astronauts who lived aboard as part of the Shuttle Mir program. This collaboration was particularly significant as it occurred during and after the fall of the Soviet Union, demonstrating how space exploration could bridge political divides and bring former adversaries together in pursuit of common goals. Life aboard Mir wasn't always easy. The station faced numerous challenges, from fires to collision damage, computer failures, and the constant battle against aging systems. Yet these challenges provided invaluable lessons that would later inform the design and operation of the International Space Station. Each crisis overcome, each repair completed, added to humanity's knowledge of how to live and work in space. The era of early space stations demonstrated that humans could not only visit space, but could actually live there for extended periods. These orbital outposts served as crucial stepping stones, teaching us the lessons we would need to establish a permanent human presence in space. They showed us that the challenges of living in space weren't just technical, but human, requiring us to understand not just the physics of spaceflight, but the psychology and physiology of space habitation. From Skylab's dramatic repair to Mir's record-breaking endurance, this era marked humanity's transition from space visitors to space inhabitants. The knowledge gained during these years would prove invaluable in the next phase of space exploration, as nations would come together to build an even more ambitious project, the International Space Station. When the Space Shuttle Columbia first rose from Launch Pad 39A at Kennedy Space Center on April 12, 1981, it marked the beginning of what would become one of the most ambitious and complex chapters in space exploration. For the first time in history, humans had created a spacecraft that could be used again and again, promising to make access to space routine and, eventually, more affordable. The Space Shuttle represented a radical departure from everything that had come before. Unlike the capsules of the Mercury, Gemini, and Apollo programs, this was a winged spacecraft that could glide back to Earth and land like an airplane. It was an engineering marvel, part rocket, part spacecraft, part glider, and remains to this day the most complex vehicle ever built. The orbiter, with its distinctive black and white thermal protection tiles, became an iconic symbol of space exploration that would define an entire generation. The program's early years seemed to validate NASA's vision of routine space access. The shuttle proved itself capable of deploying satellites, capturing and repairing failed spacecraft, and serving as a platform for scientific research. It enabled the launch of the Hubble Space Telescope, which would revolutionize our understanding of the universe, and later supported multiple missions to repair and upgrade the telescope. The shuttle also played a crucial role in constructing the International Space Station, delivering massive modules and supporting structure that would have been impossible to launch any other way. However, the program's history would be forever marked by two devastating tragedies that reminded the world of the inherent risks of spaceflight. On January 28, 1986, the Space Shuttle Challenger broke apart 73 seconds after launch, claiming the lives of all 7 crew members, including schoolteacher Krista McAuliffe. The disaster, broadcast live on television and witnessed by millions, including countless schoolchildren who were watching McAuliffe's planned journey to space, shattered the illusion that spaceflight had become routine. The investigation that followed revealed not just technical failures, the infamous O-ring that failed in the cold Florida morning, but organizational issues within NASA that had allowed known risks to be accepted. The program was grounded for nearly 3 years as NASA worked to redesign the solid rocket boosters and reform its safety culture. Then, on February 1, 2003, tragedy struck again when Columbia broke apart during re-entry, claiming another 7 lives. The physical cause was damage to the orbiter's wing, sustained during launch when a piece of foam insulation broke free from the external tank and struck the leading edge. But once again, the investigation revealed deeper organizational issues that had allowed risks to be normalized over time. Despite these devastating losses, the Space Shuttle program achieved remarkable successes during its 30-year run. It launched 355 individuals from 16 different countries into orbit. The 5 orbiters, Columbia, Challenger, Discovery, Atlantis, and Endeavour, flew a combined total of 135 missions, spent 1,322 days in orbit, and traveled nearly 500 million miles. They deployed numerous satellites, including the Hubble Space Telescope and the Galileo probe to Jupiter, conducted countless scientific experiments, and enabled the construction of the International Space Station. The program's legacy is complex and multifaceted. While it never achieved its goals of truly routine and affordable access to space, each launch remained an expensive and complex undertaking. It demonstrated capabilities that no other spacecraft has matched before or since. The ability to capture, repair, and redeploy satellites, conduct complex assembly operations in orbit, and return large payloads to Earth remains unique to the shuttle. Perhaps most importantly, the Space Shuttle program transformed our understanding of what it means to work in space. It showed that complex operations could be conducted in orbit, that spacecraft could be maintained and repaired in space, and that international cooperation could achieve remarkable goals. The lessons learned from both its successes and failures continue to influence spacecraft design and space program management today. As the program drew to a close in 2011, with Atlantis making the final landing on July 21st, it left behind a mixed legacy of triumph and tragedy, of ambitious goals both achieved and unmet. The Space Shuttle era demonstrated both the remarkable capabilities and the inherent risks of human spaceflight, lessons that continue to shape our approach to space exploration today. The end of the shuttle program marked not just the retirement of a vehicle, but the close of an era in spaceflight. While new vehicles would eventually take its place, none would match the shuttle's unique combination of capabilities. The program's greatest legacy may be the knowledge it provided about spacecraft design, about orbital operations, about organizational safety, and about the fundamental challenges of making space access routine, knowledge that continues to influence space exploration today. The dawn of the 21st century marked the beginning of a new era in space exploration, one where private companies would step forward to reshape our approach to reaching the stars. This commercial space revolution would prove as transformative as the early days of the space race, but with a crucial difference. It would be driven not by government agencies, but by entrepreneurs with bold visions and private capital. At the forefront of this revolution stands SpaceX, founded by Elon Musk in 2002. When Musk first announced his intention to make spaceflight more affordable by developing reusable rockets, many industry veterans dismissed the idea as impossible. The cost of accessing space had remained remarkably constant for decades, with launch prices hovering around $10,000 per pound to orbit. But much like how computer prices plummeted as technology advanced, from millions of dollars for early mainframes to today's affordable smartphones, SpaceX would dramatically reshape the economics of spaceflight. The company's journey wasn't easy. The first 3 launches of their Falcon 1 rocket failed, nearly bankrupting the company. But on September 28, 2008, Falcon 1 successfully reached orbit, becoming the first privately developed liquid fuel rocket to achieve this feat. This success marked just the beginning. SpaceX would go on to develop the Falcon 9 rocket, and in December 2015, achieve something once thought impossible, landing an orbital-class rocket booster for reuse. The impact of reusability on launch costs has been revolutionary. Just as the price of computing power has dropped exponentially since the 1960s, following Moore's law, the cost of reaching orbit has plummeted. SpaceX's Falcon 9 can now deliver cargo to orbit for around $2,500 per pound, a reduction of 75% from traditional launch costs. This dramatic decrease has opened up new possibilities for satellite deployment, space research, and human spaceflight. Not to be outdone, Jeff Bezos's Blue Origin has pursued its own path to the stars. While SpaceX focused initially on orbital launches, Blue Origin began with suborbital flights, developing their New Shepard vehicle for both scientific missions and space tourism. The company's motto, Gradidem Ferociter, step by step, ferociously, reflects their methodical approach to developing space technologies. Blue Origin achieved their own milestone in reusability when New Shepard successfully landed after a suborbital flight in November 2015. Meanwhile, Richard Branson's Virgin Galactic took a different approach to making space more accessible. Instead of traditional vertical rocket launches, Virgin Galactic developed Spaceship Two, a spaceplane carried to high altitude by a specially designed aircraft before igniting its own rocket motor. This approach builds on the legacy of the X-15 research aircraft and Spaceship One, which won the Ansari X Prize in 2004 for achieving private suborbital spaceflight. The future of space tourism stands as one of the most exciting prospects of this commercial revolution. What was once the exclusive domain of government astronauts is becoming accessible to private citizens, albeit wealthy ones for now. Virgin Galactic and Blue Origin have both begun flying paying customers on suborbital flights, offering a few minutes of weightlessness and a view of the Earth's curvature. SpaceX has gone further, flying private citizens not just to the edge of space, but to orbit, with missions to the International Space Station and dedicated civilian orbital flights. These developments are just the beginning. SpaceX's massive Starship vehicle promises to further reduce launch costs and enable missions to the Moon and Mars. Blue Origin is developing its New Glenn orbital rocket and planning its own lunar lander. Virgin Galactic envisions a network of spaceports enabling point-to-point travel around the globe. Other companies are developing space hotels, private space stations, and even facilities for manufacturing in orbit. The impact of this commercial revolution extends far beyond tourism. Cheaper access to space has enabled the deployment of vast satellite constellations providing global internet coverage. It has made space more accessible to smaller countries and companies, democratizing access to orbit. The increased launch capacity has enabled new scientific missions and commercial ventures that would have been economically unfeasible just a decade ago. Looking ahead, the commercial space sector continues to expand and evolve. New companies are entering the market, developing innovative technologies and business models. The dream of regular space travel, once limited to science fiction, is becoming reality. While challenges remain, including safety concerns, environmental impacts, and space debris management, the trajectory is clear. Space is no longer the exclusive domain of government agencies. The commercial revolution has transformed space from a frontier to a marketplace, from an arena of national competition to one of entrepreneurial innovation. As we look to the future, it seems clear that this commercial revolution will continue to accelerate. Just as the personal computer revolution transformed our world by making computing accessible to everyone, the commercial space revolution promises to transform our relationship with space by making it increasingly accessible to private enterprise and, eventually, to ordinary citizens. The most remarkable aspect of our journey to the stars isn't found in the rockets we've built or the distances we've traveled. It lies in how this great adventure has fundamentally transformed us as a species. Each step we've taken beyond Earth's atmosphere has not only expanded our technological capabilities, but has profoundly altered our understanding of ourselves and our place in the cosmos. When we first ventured into space, we went seeking new worlds, but perhaps the most significant discovery was a new perspective on our own world. The image of Earth rising over the lunar horizon, captured by Apollo 8 astronauts in 1968, sparked a revolution in human consciousness. For the first time, we saw our planet as it truly is, a fragile blue oasis floating in the vast darkness of space, with no visible borders between nations. This single photograph catalyzed the environmental movement and gave birth to a new understanding of Earth as a unified, living system. Each mission into space has served as a mirror, reflecting back fundamental truths about human nature. The space race showed us both our competitive drive and our capacity for unprecedented collaboration. When thousands of people worked together to achieve the seemingly impossible goal of reaching the moon, we discovered the extraordinary things we could accomplish when united by a common purpose. Our tragedies in space, the losses of Apollo 1, Challenger, and Columbia, taught us profound lessons about hubris and humility. These painful moments revealed both our vulnerability and our resilience. Each disaster forced us to confront our limitations and assumptions, leading to deep soul-searching about the true costs and meaning of exploration. Yet each time, we found the courage to return to space, wiser and more determined than before. The International Space Station has become a powerful symbol of what humanity can achieve when we set aside our differences. In orbit, traditional rivalries dissolve. American astronauts and Russian cosmonauts work side by side, sharing meals, challenges, and victories. The station stands as a testament to our ability to transcend political boundaries in pursuit of knowledge and understanding. Space exploration has also transformed our perspective of time and possibility. When we look up at the stars now, we no longer see just points of light, we see destinations. The planets and moons of our solar system have become real places, with landscapes we've photographed and soil we've analyzed. Mars is no longer just a red dot in the sky, but a world we're actively planning to visit and perhaps to settle. Our journey into space has accelerated technological innovation in ways that touch every aspect of modern life. From satellite communications to weather forecasting, from GPS navigation to water purification systems, space technology has become deeply woven into the fabric of our daily existence. But more than just technological advances, space exploration has given us new ways of thinking about problems and possibilities. The overview effect, the cognitive shift reported by astronauts when seeing Earth from space, has taught us about the power of perspective. Those who have floated above our planet describe a profound change in their understanding of humanity's place in the universe. They return with a deeper appreciation for Earth's beauty and fragility, and a stronger sense of our fundamental interconnectedness. Each new discovery in space has raised as many questions as it has answered, teaching us humility in the face of the universe's vastness and complexity. The search for life on other worlds has led us to better understand the precious nature of life on Earth. Our efforts to survive in the hostile environment of space have highlighted the importance of preserving the delicate balance of our own planet's ecosystems. Perhaps most importantly, space exploration has given humanity something it desperately needs: hope. In an age often characterized by division and short-term thinking, space exploration reminds us that we are capable of long-term planning, international cooperation, and achieving what seems impossible. It shows us that the dreams of science fiction can become reality through dedication, innovation, and collaboration. As we stand on the brink of a new era in space exploration, with plans to return to the moon and venture to Mars, we carry with us these transformative lessons. Each step into the cosmos has changed us, making us more aware of our capabilities, our responsibilities, and our fundamental unity as a species. The greatest discovery of space exploration may not be what we've found out there among the stars, but what we've learned about ourselves in reaching for them. The journey from Sputnik's simple beeping signal to today's ambitious plans for Martian colonies represents one of humanity's most remarkable achievements. In just 65 years, less than a human lifetime, we've transformed from a species that had never ventured beyond our atmosphere to one that maintains a permanent presence in space and seriously discusses becoming multiplanetary. This extraordinary progression puts us at a unique vantage point to consider what the next 65 years might hold. If we've come this far since Sputnik's first orbital journey, where might we be by 2089? The pace of innovation, particularly in the commercial space sector, suggests we're on the cusp of even more dramatic developments. We're witnessing the emergence of technologies that once existed only in science fiction. Reusable rockets now land themselves with precision that would have seemed magical in 1957. Private companies are not just launching satellites, but planning permanent settlements on other worlds. The cost of reaching orbit continues to plummet, opening space to an ever wider range of possibilities and participants. Looking ahead, several trajectories seem clear. First, the commercialization of space will likely accelerate. Just as the early internet evolved from a government project into a transformative commercial ecosystem, space is becoming an arena for private enterprise and innovation. We may see orbital manufacturing facilities producing unique materials impossible to create under Earth's gravity, space hotels catering to tourists, and private research stations conducting groundbreaking experiments. Mars looms large in our future plans. Multiple organizations, both public and private, are developing technologies and strategies for establishing permanent human presence on the red planet. These efforts will likely drive innovations in life support systems, radiation protection, and closed-loop ecosystems, technologies that could have profound applications on Earth as we face our own environmental challenges. The Moon, our closest celestial neighbor, is likely to play a crucial role as a proving ground for these technologies. The planned lunar bases and research stations will serve as stepping stones to Mars, allowing us to test crucial systems and develop experience in maintaining human presence on another world. The Moon may also become an important source of resources, with its water ice potentially being converted into rocket fuel for deeper space missions. Beyond Mars, the next 65 years might see humans exploring the asteroid belt, establishing research stations on the moons of Jupiter and Saturn, and developing new propulsion technologies that could take us even further. The James Webb Space Telescope's successors might identify potentially habitable worlds around other stars, transforming our understanding of our place in the cosmos. But perhaps the most exciting possibilities are the ones we can't yet imagine. Who in 1957, listening to Sputnik's beep, could have predicted today's reusable rockets and plans for Martian cities? The next 65 years will likely bring innovations and discoveries that would seem like pure fantasy to us today. What seems certain is that our future is increasingly tied to space. The technologies we develop for space exploration will help us address challenges on Earth, from climate change to resource scarcity. The perspective we gain from looking back at our planet from space will continue to influence how we think about our world and our place in it. As we conclude this journey through the history of space exploration, we invite you to join us in imagining and building this exciting future. Our next episode will take a detailed look at what life on Mars might actually be like, from the practical challenges of living in a hostile environment to the day-to-day realities of being among the first humans to call another planet home. If you've enjoyed this exploration of our spacefaring history and want to continue discovering the wonders of the universe with us, please remember to subscribe to our channel and share this video with others who share your fascination with space. Together, we can continue to push the boundaries of what's possible and explore the final frontier. Join us next week as we dive deep into the realities of Martian living, from radiation protection and growing food in Martian soil to the psychological challenges of living millions of miles from Earth. You won't want to miss this fascinating glimpse into humanity's potential future on the red planet. The beeping of Sputnik may have fallen silent long ago, but the echo of that historic moment continues to resonate as we push further into the cosmos. The next 65 years promise to be even more extraordinary than the last, and we invite you to be part of this incredible journey.